Hello and welcome to today's lesson. I'm your hard-working but indefatigable teacher, Mr. Burton. You will need to watch this video and take notes as you go. You may need to watch certain parts of the video a few times to ensure complete understanding. This is your homework and I will check your notes tomorrow before we get started. I hope you learned something.
Okay, today's topic is cross-price elasticity of demand. Our second installment in our elasticity unit. Okay, what is cross-price elasticity of demand?
Cross-elasticity of demand measures the quantity demanded of one good in response to a change in price of another. If two goods can be substituted for one another, consumers will usually buy one when the price of another increases. For example, if the price of butter increases and everything else stays the same, the demand for margarine is likely to grow as consumers try a substitute. Calculate the cross-elasticity of demand by taking the percentage of change in the quantity demanded of one good and dividing it by the percentage of change in price of a substitute. Positive cross-elasticity means that if the price of one good goes up, demand for another does too. With negative cross-elasticity, an increase in the price of one good causes a drop in the demand for another. Complementary products demonstrate this concept. If the price of coffee increases and everything else stays the same, the quantity demanded for stir sticks will drop too. If the calculation yields a small value, then the two goods have little relation. Cross-elasticity of demand really only applies in situations where the two products or services are related in some way. For instance, an increase in the price of shoes is likely to have little bearing on the demand for plastic cups.
Okay, so cross-price elasticity of demand, we're looking at goods that are complements to each other and goods that are substitutes to each other. So specifically, XCD measures the responsiveness of the quantity demanded for a good to a change in the price of another good. So we know a change in the price of a related good will shift the demand curve, and cross-price elasticity will give us a good indication of what is occurring. Right, we know what substitute goods are, just a quick reminder.
A substitute is a good that satisfies the same needs as another. A substitute can be perfect or imperfect, depending on the degree of customer satisfaction. For example, if a consumer substitutes Coke for Pepsi and is completely satisfied, then Coke is a perfect substitute for Pepsi. If a consumer is not completely satisfied with the exchange, finding some difference between the two products, then one is an imperfect substitute for the other. Consumers use substitute goods when the price of one product increases and compels them to find an alternative that's less expensive. Two close substitute goods have a positive cross-elasticity of demand. For example, if the price for Pepsi went up, so too would the demand for Coke. If two goods are not close substitutes, a change in one's price will not impact the demand for the other. Pepsi's price would probably not be affected by a rise in the cost of milk.
Okay, when we go away and do our XCT calculations, it can tell us whether the two goods are substitutes or not, and it can tell us the strength of the relationship between the two goods, whether they're close substitutes or weak substitutes to each other. So on the left here we have good A. Initial equilibrium price and quantity. Decrease in supply will push up the price, reduce the quantity demanded and supplied. So price rise for good A, P1 increases to P2. Does this have an effect on good B? If the two goods are substitute goods, then yes, that price increase for good A should drive the demand higher for good B. Okay, so price rise for good A, P1 increases to P2. An increase in demand for good B is the result. QD1 increases to quantity demanded 2. And the specific value of XCD, which you'll learn how to calculate in a minute, will provide important information to show how much the quantity demanded of good B is going to change in response to increases or decreases in the price of good A. Complement goods, quick definition, quick video explainer.
A good or service that's used in conjunction with another good or service is a complement. Companies and economists study complementary goods to understand consumer decisions and buying patterns. Complementary goods have little to no value when they're consumed alone, but when combined with another good or service, both benefit through added value. The demand and price of one product can drive demand for another product if they're complements. For example, when the demand for hot dogs rises, there will be more demand for hot dog buns. On the other hand, if the price of hot dogs climbs high enough to deter customers from buying them, the demand for hot dog buns will decrease as well. But if the price of steak rises to the point where fewer consumers are buying it, they may turn to a less expensive option, hot dogs. Demand for hot dogs and hot dog buns will then rise together. Many businesses looking to increase sales search for the right combinations of complementary goods. A toy store may also offer batteries, for example, or a dry cleaner can also offer tailoring services.
Okay, so there should be no surprise here. We've been here, this is in our demand topic. One of the things that would shift the demand curve is a change in the price of a complement. A decrease in the price of a complement will increase demand for the other good. Okay, let's have a look at cross-elasticity of demand and complementary goods. Good A, the initial equilibrium, determines the price and the quantity. A decrease in supply will increase the price. What effect will this have on a complementary good, good B? Okay, so a price rise for good A, if they are complementary goods, good A and good B are complements, then as P1 increases to P2, because the quantity demanded decreases from Q1 to Q2, and these goods are purchased together, consumed together, there's going to be a decrease in the quantity demanded for good B. So a price rise for good A, P1 increases to P2, that price rise and the decrease in the quantity demanded for good A is going to lead to a decrease in demand for the complement good, good B. QD1 decreases to QD2. And again, the value of the XCD coefficient, which we're going to learn how to calculate just now, is going to provide important information as to how much of a quantity demanded of good B is going to change in response to increases or decreases in the price of good A. Are these two goods strong complements? Are they weak complements? Okay, here we are looking at our calculations. Just like with price elasticity of demand, we've got a formula. You won't be given the formula in the exam, but it's pretty easy. Again, it's quantity demanded that's going on top and the price change on the bottom. So percentage change in quantity demanded of good X over the percentage change in good Y. And again, as with price elasticity of demand, Queen is on top, Prince is on the bottom. Queen is above the Prince. Quantity is above price in our equation formula. Okay, let's have an example calculation here. If the price of good A decreases by 10%, the quantity demand of good B increases by 7.5%. Just plug that into the calculation. This time, whether it's a positive or a negative change is important. So here we've got an increase in quantity demanded by 7.5, so that's positive. And we've got a price decrease, so that's negative. And we need those integer values to make sense of this. So unlike PED, price elasticity of demand, the positive, which signals an increase, and the negative, which signals a decrease, are very important to our cross-price elasticity of demand calculations. So again, if the information in the question is not presented in terms of percentages, we need to be able to work that out. We need to get the percentages there taken care of. Okay, so here's an example calculation. The price of good A decreases from $10 to $9, and the quantity demand of good B decreases from 1,000 units to 880. So we got that percentage change in price, and this time it's a decrease in price, and it decreases by the 10%. That's why we've got the negative 10% there. Change in quantity demanded, this decreases as well, and that turns out to be negative 12%, because we have a decrease in the quantity demanded of good B. It's a decrease of 12%, so that's negative as well, a negative value. Into our formula there, negative 12 divided by negative 10, and out pops our XED coefficient, positive 1.2. So again, we need to make sure we get our positive and negative signs correct. Very important to our calculations. Okay, so what do these coefficients tell us? If our XED coefficient, the number that pops out after we've performed our calculation, is negative, we know we're looking at complement goods. And so we can interpret this in the following way. An increase in the price A leads to a decrease in quantity demanded for good B. So, for example, price A increases by 10%, quantity demanded for B decreases by 8%. That's a complement. And conversely, a decrease in the price of A leads to an increase in the quantity demanded for B. And the higher our XED, the stronger the complements are. So, for example, two goods with an XED of negative 0.7 are stronger complements than two goods with an XED coefficient of negative 0.3. And that means that a price change of a strong complement is going to result in a proportionally large change in the quantity demanded for the other good. Now, if a value is greater than 0, this means it's positive. It's going to tell us that we're looking at two substitute goods. And the interpretation there, an increase in the price of good A leads to an increase in the quantity demanded for good B. So, for example, as price A increases by 10%, quantity demanded for B increases by 8%. Substitutes. Or a decrease in the price of A leads to a decrease in the quantity demanded for good B. Again, the higher the value, the stronger that value, the higher the degree of substitutability. So, for example, two goods with an XED of 0.8 are far stronger substitutes than two goods with an XED of 0.3. The price change of a strong substitute is going to result in a proportionally large change in the quantity demanded for the other good. Whereas with a weaker XED coefficient, the price change of the substitute won't result in as much change in the quantity demanded for the other good. Now, if we find out that XED is 0, we're talking about unrelated goods. So an increase or decrease in the price of good A won't affect won't affect quantity demanded for good B at all. So, for example, if the price A increases by 10%, quantity demanded for B remains unchanged. And XED equals, if we find out that's an infinite value, then we are talking about perfect substitutes. Perfect substitutes. So a decrease in the price of A leads to 0 sales of B, because everybody immediately switches to good A. Okay, so what are the implications for cross-price elasticity of demand, and how does it affect businesses? Okay, so there's several important implications for businesses if prices change. And we're going to look at these each in turn. So, substitutes produced by a single firm substitutes produced by rival firms, substitutes and mergers and acquisitions between firms, and complement goods. Let's have a look at each of these now. Right, substitutes for a single firm. If a firm is producing a line of products that are similar, it's essential that the firm considers cross-price elasticity of demand when they make their pricing decisions. So, for example, General Motors, that US car manufacturing company, they are going to produce many different models of motor vehicles under a variety of brands. So, for example, if it decides to discount the Chevy Volt, for example, then it needs to know how that discounting of the Chevy Volt, so sales there are going to increase. They need to know how sales of the Chevy Bolt, the Cadillac CT6, Buick, Opel, Cascadia, etc., how these are all going to be affected by that price change in one of its other models. So the Chevy Bolt, if it's discounted, perhaps a large increase in quantity demanded for the Chevy Bolt. Now this is a low profit margin product for General Motors. And perhaps that's going to result in a large decrease in the quantity demanded for the Cadillac, which is a high margin product for General Motors. So it's going to drive an increase in demand for the Chevy Bolt, low profit if it discounts the price there, and the effect there on other brands, other models, other products that the firm makes is going to be a large decrease in this case. So there's no way General Motors, armed with its cross-price elasticity of demand information between the two products, is going to decrease the price of a low profit margin product, because that's going to negatively affect sales of a high margin product. So it's not enough to know what the different products within a line of goods or services are substitutes with each other, which in the case of General Motors vehicles, the different products undoubtedly are. It's also necessary to know the strength of that substitutability. Different products within a line of products will often have different profit margins associated with each. So this, if we're discounting the low margin Chevy Bolt, results in a steep decline in high margin GM cars such as the Cadillac, then General Motors could reasonably expect its total revenues and or its profitability to decrease. On the other hand, if GM discounts the Chevy Bolt and knows it will not affect its high profit margin cars, say its SUVs and premium brand vehicles, then it's much more likely to increase total revenues and overall profitability. So very important for a single firm that has different products that may be substitutes for each other. Now, substitutes with rival firms, this is very important as well. So firms are going to be keenly interested in the cross-price elasticity of demand between their own products and that of rival firms. So, for example, General Motors would be really interested in knowing the cross-price elasticity of demand between its own brands and models and those of rivals such as Toyota and Nissan, other car manufacturing companies. If General Motors has strong product differentiation and thus relatively low substitutability between its products and of its rivals, then it may be relatively unaffected by price decreases in rival products. However, if the XCD is high, then GM would need to quickly review its prices when a competitor such as Toyota lowers its prices in order to protect the firm's market share. So if Toyota drops its prices, there's high substitutability between Toyota brands and GM brands. The price decrease for Toyotas is going to drive customers towards Toyotas and away from General Motors. General Motors is going to lose revenues and market share as a result. So take, for example, the Toyota Prius. A price discount there from $50,000 to $45,000 would result in a large increase in the quantity demanded for this good. And if the substitutability between the Toyota Prius and the Chevy Volt was large, a strong substitute existed here, then that price decrease and the large increase in quantity demanded for the Toyota model is going to drive a large decrease in demand and quantity demanded for the Chevy Volt. So it's essential that rival firms are aware of cross-price elasticity between the two substitute rival products. Now, in terms of mergers and acquisitions, a merger is a deal to unite two existing companies into one new company, and an acquisition is a corporate action in which a company buys most, if not all, of the target company's ownership stakes in order to assume control of the target firm. Now, firms that have rival products that are close substitutes may be interested in acquiring a rival firm or merging the two firms into one firm, because this is going to reduce the competition, which will in turn allow firms to increase prices to increase their total revenues and their total profits. So an example would be Fiat, which was an Italian car manufacturer, acquisition of Chrysler, a US car manufacturer. Complementary goods. Now again, this is important for firms to know. It's useful for firms to know the cross-price elasticity of demand regarding complement goods when making pricing decisions. Goods that have weak XED because they're not strongly related don't have little interest in this. But goods and services that have strong negative XED relationships mean that decreasing the price of one good or service is going to strongly boost sales of the other good or service. So let's have a look. For example, some firms will produce a range of goods and services that are strong complements to each other. And probably the best example out there are razors and razor blades. So the two giant firms in the market here, Gillette and Schick, know that if they can sell more of their razors to consumers, then those very same consumers are going to very likely to purchase the associated razor blades. Both of these companies sell their razors at a loss. We call this a loss leader in the business. And because their razors are so cheap, this increases the demand for their high-priced razor blades. Once the customers bought the razors, then they're sort of locked into purchasing the complement good and the razor blades, and these can be charged at a higher price.